With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is asking that dipole moment of aldehyde and ketones are higher than that of alcohol. Why? So basically why it is that dipole moment of aldehyde and ketone is higher than alcohol. So let's suppose we are talking about this in general, this carbonyl group. So it will be either aldehyde or ketone, that will be depend on this R1 and R2 group. If one of this R1 and R2 is taken as hydrogen, so then that will be aldehyde, and if both R1 and R2 are taken as alkyl group, then that will be ketone. Now what about alcohol? So in alcohol we will have this OH group, and it may be 1 degree, 2 degree or 3 degree, depend on that it will be connected by this alkyl group. So again this will be taken as R1 dash, R2 dash and R3 dash, because here already we have taken R1, R2. This R1 dash, R2 dash and R3 dash can be hydrogens or any alkyl group. Now if I am talking about the electronegativity difference, then this oxygen will have a more electronegative and this carbon is less electronegative, and because of that it will have a partial negative charge and it will have a partial positive charge. Now what is dipole moment? So let's suppose A and B is any molecules, and out of this, if B is more electronegative atom than A, B is more electronegative than A, then in that conditions B will have a partial negative charge and A will have a partial positive charge, and here one polarity is developed, and that polarity will create a dipole, and dipole will be from this positive charge towards negative charge, from positive to negative. So here we can say from positive to negative, here dipole will be there, one dipole. This will be called as bond moment, because this is not a net dipole, this is an individual bond moment. Here also this carbon basically will have a sp2 carbon, and if R1 and R2 is carbon, means alkyl group, then it will be sp3, and sp3 carbon is less electronegative atom than this sp2. So out of these two, this is more electronegative atom, so dipole will be something like this, from this alkyl group to this carbon side. In the same way here also one dipole will be created. Now as we can see, these two dipoles, because dipole is a vector quantity, this is a vector quantity, basically vector quantity. So remember that dipole is a vector quantity. So we can, as we can see, all the are going in the same directions, so it will be added. It will be added, an angle between these two vector means if we extend the angle between these two vector means one is going in this direction and one is going in this direction, and angle between them is basically 120 degree angle, and here one dipole is there in between them. So all these dipole will be added here, and the net dipole moment can be calculated as under root of nu1 square. Let's suppose two dipole we are adding, plus nu2 square plus twice of nu1 nu2 cos theta. So this is the formula. Now if I am talking about the alcohol, then in alcohol also this OH is there, but here the electronegativity difference will be less as compared to this one, because here double bond is there, and because of double bond here the charge created will be more as compared to this one. Here also charge will be created, but that charge will be very less, and because of that this dipole moment also will be very less. And here also this dipole will be there in the same way, this dipole. But if you find the resultant of this dipole, because this R1, R2, R3 can be hydrogen as well, and if this R1, R2, R3 is taken as hydrogen, in that case there will be no dipole moment, because hydrogen is taken as a reference element, and because of that there is no dipole moment. So if you find the net dipole moment of this compound, then that will be basically less than, this is the alcohol, that will be less than dipole moment, net dipole moment of aldehyde, ALD, aldehyde, and ketone, ketone. Because in case of ketone, here double bond is there, here charge creation will be more as compared to this one, and because of that it will have more strength of dipole as compared to alcohol. So finally we can say this alcohol will have a less dipole moment than of aldehyde, because of this electronegativity difference, because this has a double bond. So if you find the oxidation state, then this oxygen will have a -2 oxidation state because of this carbon, and this carbon will have a +2 oxidation state because of this carbon only. We don't know about this R1 and R2. So from there carbon will affect, and the final oxidation state will be changed. Now here if I am talking, then it will be -1, it will be +1. So from here also we can see here charge creation is -2, but here the charge creation is -1. as well. So from here also we can say it will have a more dipole moment as compared to second compound. So I hope you understand this concept. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.